use of renewable energy is not new to Australia. Windmills for pumping water give the Australian landscape much of its character. Many rural areas still rely on wood stoves for water heating and cooking. Major dams provide hydroelectricity to metropolitan areas. And today, Australia, in common with the rest of the world, is seeking to develop renewable energy sources and technology in tandem with its coal, oil, and natural gas resources. Power derived from water, crops, wind, and the sun is the new energy frontier for Australia. The water wheel is the simplest use of the power of water and has been used for centuries for milling grain. It's not high technology and not very efficient either. This rough, homemade wheel provides electricity for a remote Tasmanian homestead. A far more efficient way of converting water power to electricity is the water turbine, although the principle is not so very different. Water is conducted downhill to build up pressure and turns a small wheel which is connected to an alternator. The power that can be obtained from a stream of water depends on the amount of water flowing and the height from which it flows down to the turbine. Starting up is simply a matter of opening a valve to allow the water stored in the pipe to pass to the turbine. This prototype produces 3 kilowatts, 24 hours a day, 365 days of the year. The lifetime of the turbine is between 50 and 70 years, and it requires very little maintenance. Like many renewable systems, water turbines can require some modification of the user's lifestyle. When the turbine is operating, it produces power continuously, so the user may often, at some time of the day or night, have surplus power. And of course, there is no storage system. But the surplus power costs nothing, and in fact, this turbine is only turned off when the water level in the dam is low. This mini hydro installation regulates the current by consuming surplus electricity through a series of hot water heaters. The water turbine provides enough clean, smooth, and quiet power for an average homestead. Both the type of turbine and the amount of power produced are determined by the water flow and the pressure that can be built up by conducting the water downhill. This fall need not be as spectacular as a mountain gorge, but can be accomplished over some distance in more gentle country. Every site varies, and fall and water flow must be accurately measured. In most cases, mini hydro systems must be specially designed for each site. Hydroelectric systems have been around for many years. Water turbines for specific, smaller and more remote uses are a recent development. Water is an abundant resource in only a small part of Australia. Indeed, lack of water moulded our recent history, governing the progression of European settlement. Until the discovery of underground water and the development of a cheap means of pumping it, European settlement was confined to a narrow band along the southeast Australian coast and to a few river outlets elsewhere. That crucial machine, the cheap water pump, relies on a renewable energy source that is ever present, even in the desert: wind. 30 years ago, an Australian company pioneered a new application of the windmill in rural Australia, the generation of electricity for remote homesteads. This homestead has all its electrical lighting powered by this small wind generator. Wind generators such as this generally require a storage system and a backup diesel generator. Today, these small wind generators are scattered throughout Australia, and the range of their uses has widened. There are a number of remotely located small-scale uses: marine buoys, radio communications, and lighthouses. And here, to power the radio of a remote forestry watchtower, even to charge the batteries of an ocean-going catamaran. A revolution of scale is going on here too. In this case, the aim is to develop bigger and more efficient wind generators.
There it is. Yeah, okay. Going around there, isn't it? Yeah, it is.
This 5-kilowatt generator satisfies all the power requirements of an average home. Wind generators require complex control, safety, and storage systems. As with water turbines, to some extent the users must modify their lifestyle. Although wind generators are manufactured in a range of voltages, the most common is 110 volts DC. As a result, normal household appliances may have to be modified. Furthermore, the storage system has a fixed capacity, and power consumption needs to be carefully monitored. Wind generators on this scale are still something of an experiment, not so much in terms of technology, but in cost and economy. On an island off the West Australian coast, a much larger scale experiment is taking place. The island is a resort complex powered primarily by a large diesel generator. As with all islands, the provision of liquid fuels for power generation and transport is costly. It had been hoped that wind power might help the island economize. Wind generators feed into the island's power grid. Power generation from wind on this scale is still experimental. It was hoped that these wind generators would provide 10% of the island's power, but after a year's monitoring, they've only provided 2%. However, for smaller scale and more remote uses, wind generators are a promising alternative. There is another renewable energy source that can be efficiently tapped, even in the heart of the Australian city: the sun itself. Australia is a pioneer in the development of solar hot water systems. In Perth, Western Australia, 1 home in 10 uses solar hot water. 10,000 new units are installed each year. All Australian cities receive enough sunshine to operate solar systems. Their economics very much depend on location factors, such as cost of electricity from the grid and intensity of sunshine, but they're already an economic alternative in many parts of Australia. The simplest system uses a flat plate absorber panel. Water is circulated through tubes in a black painted metal panel. After being heated by the sun's radiation, the water rises to a highly insulated tank and is drawn off as needed. The flat plate panel system is modular. More hot water can be obtained by simply adding more panels. The amount of hot water available is limited only by the roofing area. This factor opens up commercial applications. Still something of an experiment is the provision of hot water for industrial uses. In this case, in the beer pasteurising process at a South Australian brewery. However, many small-scale residential complexes all over Australia are finding panels a realistic alternative for domestic hot water. A caravan park in Queensland. A large complex of homes for the aged. A new remand centre in Western Australia. A recent innovation integrates collectors into the roof itself, instead of simply attaching panels to it. These systems have the advantage of maintaining the original character of the home, the original roof line. Here, the roofing heats a domestic swimming pool. And integrated systems are also, in a sense, modular. The amount of heating available is limited only by the area of the roof. This system is heating the 3 swimming pools of a large hotel. Integrated roofing systems have the further advantage of being very light. Flat plate panel systems are restricted in size by the structural strength of the roof. Both the flat plate and the integrated roofing systems produce water at a fairly low temperature, suitable for domestic uses, for heating swimming pools, and for low-grade commercial uses. Research continues now on 2 fronts: into materials and design, to make collectors more efficient and cost-effective, and into their operation at higher temperatures and on a larger scale, so that a wider range of commercial uses becomes possible. Concentrating collectors are a new option for solar hot water heating. A highly polished metal mirror concentrates the sun's rays on a thin, black, absorbing pipe. They're usually designed to track the sun. This adds complications and costs, but makes them highly efficient. Concentrating collectors are also modular, and they can be extended for commercial applications. In this case, heating the seed shed at a plant nursery. Increasing their size may also open up a new range of applications for concentrating collectors. This is the first large-scale industrial solar hot water installation in Australia, a commercial laundry in the country town of Swan Hill, Victoria. Solar hot water systems are efficient, cheap, and suitable in all parts of Australia, both metropolitan and rural. At the moment, they're best suited to small-scale, low-temperature applications. The search continues to increase their size and efficiency to produce water at higher and higher temperatures for a wider range of commercial uses. Wind power, water power, and the trapping of the sun's heat, all ways of harnessing the energy of the sun. Comparatively recently, a new technology has made it possible to transform the light of the sun to electricity. The photovoltaic cell.
Untitled Forward to AQC. Come in, Peter.
Electricity is generated by sunlight and stored in batteries, providing DC power. This is ideal for radio and other communication equipment in remote locations, and solar cells are virtually maintenance-free. Here, a panel of cells powers a remote weather station near the heart of Australia. The station automatically transmits wind speed and direction to a distant control centre.
Yeah, Darwin, Alice Tech here. Yeah, check that low voltage line out. One on at 1445. Sequence 57. Okay, mate, call it back in about 5.
Photovoltaic panels are modular and may be made up in different configurations depending on the requirements of each specific task. This telecommunications repeater station links a town in the middle of Australia with the World Telephone Network and also relays the town's television service.
Yeah, Darwin, Alice Tech downstairs this time. Quick check around, everything seems normal. Backup pressure's okay.
The program it broke up a little bit of tearing, and then it disappeared. It's okay, incumbent to you, is it?
Where small amounts of electricity are required in remote or inaccessible regions, the solar cell is becoming more practical. They are common now for marine safety buoys, remote telephone exchanges and radio systems.
Be good? Be good?
Yeah, we'll be good. I got you that. I got you.
The expected decline in the cost of photovoltaic cells may open up a range of new applications. This pioneering homestead, far from the electricity grid, uses solar cells to provide the power for a television, a washing machine, and other household appliances.
For what we're about to see, Madam would make us truly thankful for me.
As with other renewable energy systems, some adjustment of lifestyle may be necessary. Care must be taken not to exhaust the battery storage, and some form of record kept of battery level and load requirements. Not everything can be turned on at once. The most ambitious project to date is the provision of solar power to a small Aboriginal community off the coast of northern Australia. The community wanted power for water pumping and lighting. They also wanted the source to be quiet and virtually maintenance-free. These panels power a pump which brings water 5 kilometres to the village. The village of Paru houses about 20 older people who've moved away from the main settlement. They did not want a diesel generator, the only alternative. The photovoltaic panels on the roofs provide lighting, and solar panels provide hot water. Small though it is, this is Australia's first solar-powered community. It's hoped that in years to come, this prototype can be extended to other remote communities throughout Australia. The increasing cost of traditional fuels has had an enormous impact on world economies. Australia is, to an extent, insulated from some of these problems because of its resource wealth. However, the need exists to find ways of supplementing these traditional sources. Australia is developing technology to utilise the renewable resources of the sun in many ways. This is the first Australian-built solar thermal power station. The mirrors concentrate the rays of the sun on central absorbers, where water is heated to form steam, which in turn powers a turbine generator. The electricity generated will power the isolated community of White Cliffs in New South Wales. This power station is an experiment, a prototype, but it is hoped that it may hold possibilities for other remote communities throughout Australia. Conventional power sources, oil, coal, wood, and natural gas, are simply the sun's energy trapped and stored. But the sun's energy may be trapped in almost anything: rock, sand, water. In this experiment at Alice Springs, the sun heats salt water to a temperature of 90 degrees, which powers a Rankine cycle Freon gas engine. The alternator is rated at 20 kilowatts and is to be used to power a winery and restaurant. Both the solar power station and the solar pond are experimental and costly. Perhaps more important and immediate is the search for a renewable source of liquid fuels. Throughout Australia's history, transport has been a major problem. Indeed, the early history of Australia could be called the history of transport. Most of Australia's population lives in cities, remote from our mineral and agricultural resources, and in the interior, communities are small and widely scattered. It's the vastness of the continent and this isolation which makes renewable energy research imperative. Today, research continues into economical ways of producing liquid fuels from a variety of plants. Fuels from seed oils, from sorghum, from sugarcane and sugar beet. This work is at the forefront of Australia's research into renewable energy technology. The development of appropriate technology, exploiting renewable energy sources, holds the promise of providing cheap and efficient power, in particular for small-scale and isolated uses. This work is already bearing fruit for the isolated communities in Australia and will increasingly find its way into the cities. The search goes on.